Hello everyone, today we're going to be working on fundamental problem 2.3, and this problem is asking us that if f of 1 equals 850 newtons and f of 2 equals 650 newtons, to determine the magnitude of the resultant force and also to determine the direction of the resultant force measured counterclockwise from the positive x-axis. So here we have our f1, our f2, and we could start off by labeling that F1 equals 850 newtons and F of 2 is 650 newtons. Here they already gave us that this angle is 30 degrees, and we could tell that this angle right here is a 90-degree angle, so we know that that angle right there is 90 degrees. So to find the magnitude of the resultant force, what I like doing is I like drawing out a parallelogram with the forces given to us already. So we're gonna redraw forces off to the side just so we could work with them a little more clear. So this is our f of 1 right here, and this is our f of 2. From here, we're going to take our f of 1 and we're going to draw it on the other side. We could simply just copy and paste it. And then we're going to do the same thing with our other resultant force, with our other force. I'm sorry. And then from there we could label. So this is our f of 2. This one is also our f of 2. This is our f of 1. And this one's also f of 1. Okay, so now that we have that, we know that this angle right here are these two angles summed up, which is our 90 degrees and our 30 degrees, giving us a total of 120 degrees. So these two angles are the same angles, and those are 120. And then we know that the sum of a parallelogram is 360 degrees. So what we're going to do is we're going to do 120 plus 120 plus the angles that we're missing are these two angles right here, which we know are going to be the same angles. We're going to name those angles beta. So 120 degrees plus 120 degrees plus 2 beta, so we have 2 of them, has to equal 360 degrees. And solving, we get 2 beta plus 240 to 360. 2 beta is equal to 120, giving us that beta is equal to 60 degrees. So we know that these two angles are each 60 degrees. So now that we know that, we could finally find our magnitude of our resultant force. And to find the magnitude, I like using the cosine law, as you could see here. Our cosine law is this one right here. And we could use it because our parallelogram our resultant force goes right in between, kind of, from the two resultants. So it creates two triangles. And we use the cosine law to solve for triangles. So rewriting the cosine law for in these terms using f of r, f of 1, and f of 2. So just rewriting C, A, B, and C in the terms of f of r, f of 2, and f of 1, we get f of r is equal to f of 1 squared plus f of 2 squared minus 2f of 1, f of 2 cosine beta. So now that we have that, the cosine law written out, we could plug in all our numbers into the equation. So we get f of r is equal to the square root of 650 squared plus 850 squared minus 2 times 650 times 850 times cosine of, and we said that beta was 60 degrees. All we have to do now is plug it into our calculator, and we want to make sure that our calculator is in degrees and not in radians. And once we plug that into our calculator, we should get that our magnitude of our resulting force is 769.74 newtons. So that's our answer for the first part of the question, where it asks us to find the magnitude of the resulting force. So this is the magnitude of our resulting force. Now the second part is asking us to determine the direction of the resultant force measured counterclockwise from the positive axis. So counterclockwise would be this way, because clockwise is going this way. So from the x-axis, we're going to try to find it in this direction, if that makes sense. So what we're going to do to find it is we're going to use the sine law. So this law right here, to find our direction of our resultant force from positive x-axis. So what we're going to do is we're going to write sine of theta over 850 newtons is equal to sine of 60 over 769.74 newtons. And we did this because, once again, as you could see from the sine law, that A and A go together. So this side right here is going to go with the opposite angle. This B is going to go with the opposite angle, and this side C is going to go always with the opposite angle. So it's always the side over sine of the opposite angle. So here, our resultant force would be crossing right here. So here we have our resultant force we have our resultant force right here, and it goes with the opposite angle, which is the 60 degrees. And then we're using f of 1, and then the opposite angle is, that's what we're trying to find. So sorry, I don't know why, but I had this labeled as f of 1. So what we're trying to do is, let's see if I could rephrase this. So this is our resultant force, and we already know its angle. So we have our resultant force with the corresponding angle. What we're trying to do right now is we're trying to find this angle right here, which is why we're going to be using f of 1 since it's the opposite side of the angle that we're trying to find. So now that we have this written out, we're going to solve for theta. So we end up getting sine of theta is equal to 850 newtons times sine of 60 all over 769.74 newtons. We have to make sure that our calculator is in degrees, and that should give us 0.956. And now we have to get theta by itself, so we get theta is equal to the sine inverse of 0.956. Again, calculator should be in degrees, and that should give us 72.940 degrees. Okay, so now that we found the angle that goes right here, what we're going to do is so let's see if I can zoom in a bit more. So our x-axis is right here, somewhere around there. And we're trying to find this angle going counterclockwise from the x-axis. And that's the angle that we found earlier on, which is why this is our final answer. 72.940 degrees, or if we want to round that up to 3 significant figures, it'd be 73.0 degrees. And that's how we solve for the magnitude and direction of our resultant force from our fundamental problem 2.3.